In this video, we're going to sketch a graph of a polynomial function. The first step is to determine the end behavior. Here we see the leading coefficient or leading term. The leading term is negative x to the fifth. The power is odd. So that means we're either going to have a graph that has end behavior like this, or it's going to be end behavior like that. And if the leading coefficient is negative, then it's going to be like this. Okay, so I can go ahead and draw that. Draw my end behavior a little bit. Okay, so I'm just going to draw the end behavior. I'm going to leave the rest alone. I'll fill in the rest as I go. So that's the first step, determine your end behavior, and that's going to be all by the leading term. Okay, next step is to find the zeros, which will basically be finding the X-intercepts. Alright, so let's go ahead and do that. We'll find the zeros. So we'll have 0 equals negative x to the fifth minus 5x to the fourth plus 4x cubed plus 20x squared. So to find the zeros, first thing I'm going to do is I'm going to factor. I'm going to pull out a negative x squared. So I'll be left with x to the third, then a plus 5x squared, a minus 4x, and then a minus 20. Now let's see if I can factor this. Do I see, I'm looking for common terms, so I'm going to look at this side and that side separately. So I'm going to pull out the front half, I'm going to pull out an x squared, and I'll have x plus 5. And then on the second half, I'm going to pull out a negative 4. So then I'll have x plus 5 there as well. Okay, so now I have x plus 5, x plus 5. So let's go ahead and pull that out. So I'll have x squared minus 4 times x plus 5. Right? If I were to take x plus 5 multiplied by x squared, x plus 5 multiplied by minus 4, what I get is what you see up here. So now, if any piece equals 0, then the whole thing will equal 0. So let's go ahead and set each piece equal to 0 to solve, to find all the zeros. So x equals 0, that's 1 0. X squared minus 4 equals 0. So x squared equals 4. So x equals plus or minus 2. And x plus 5 equals 0. So x equals negative 5. So I have, let's see, I have 4 zeros. X equals 0, x equals negative 2, x equals 2, and x equals negative 5. I'm going to go ahead and plot each of those here on my graph. So I have one at 5, I have one at negative 2, one at 0, and one at positive 2. Okay, so now let's talk about our multiplicity of each of these zeros. So this one has a multiplicity of 2, right? Because here you see I could have written that as x and x. So this one has a multiplicity of 2. This one here has a multiplicity of 1. Actually, all of the rest have a multiplicity of 1. They only show up once. Okay, so that means that I'll be crossing the x-axis of every one except for when x equals 0. So then I'll go like this. So when x equals 0, I'm not crossing, but I'm coming, so it's a turning point there. And then I cross again there. Alright, next step is to find the y-intercept. So let's go ahead and do that. To find the y-intercept, I plug in 0 for x. And if I do that, if I plug in 0 for x, since every term involves x, the whole thing's going to go to 0. So my y-intercept is here at 0, 0. All right? So that's my only y-intercept. And then you know, next thing that we could do is we can plug in several points just to get an idea of, you know, what's happening between these areas. So right now, you know, what's happening between here is kind of unknown. What's happening here, you know, is kind of unknown. So I could plug in several points. So to do that, so I'm going to go ahead and do that. I'm going to make a table here. So if I were to plug in x, all right, so points of interest might be, you know, some point that's between -5 and -2, for example. So I could plug in maybe -3. All right, so I could plug in -3. So I'll do that. -3. Now you can use a calculator if you want for this, or just calculate it yourself. And what you'll get is that if you plug in -3, you'll get 90. Then I might plug in a point that's between -2 and 0, such as -1. -1. If you do that, you would get 12. And then I could plug in a point between 0 and 2, such as maybe +1, and I get 18. And then I can plug in, well, that's probably enough. All right, so what I see is that I'm going up and down like crazy. So I'm going, when I cross here at 3, I'm at -90. That's like off, you know, it's really low. So I'm going really low, and then I'm going back up to 2. And I cross at -2. And then I go up to, well, I don't know how far I go up, but I know I go up to at least 12, right? I don't know where the turning point is exactly. And then I go down, and then I go up again, really high, you know, at least to 18, probably higher, right? I don't know where the turning point is, but the point is that I go up and down really extremely, really fast. Okay, and so that would be a graph of this polynomial. Of course, you know, we didn't find the turning points, so it's just a sketch. It's not exactly what the graph looks like, but you know, if you were to sketch it out, you know, it looks something like this. Okay.